Hello, in this video we are going to use composition in order to determine whether two functions are inverses. These examples are going to focus on quadratics and square root functions. So we want to determine if f of x, which is x minus 2 squared plus 3, is an inverse function with g of x. And g of x is given here, that is the square root of x minus 3 minus 2. I want to make sure that that was there. Okay. So again, remember from our first video, the step that we have to first take is we have to see, is f of g of x a function? So what I'm going to do again is I'm going to take g of x and I'm going to plug it inside f of x. And what happens is that we get our x value, which is here, ends up being, oh, I don't want to open Word. Goodbye, Microsoft Word. Sorry for that glitch. What ends up happening here is that g of x goes inside for f of x. So I get x minus 3 minus 2. Okay, so square root of x minus 3 minus 2, and that is inside here, in for x, and I'm going to subtract 2. I'm going to square that quantity, and I'm going to add 3. So there's a lot going on here, but we're just going to simplify it step by step. So I'm going to first focus on my inside parentheses here. So what I have is I have the square root of x minus 3, and I get negative 2 combined with a negative 2 is a negative 4, and I have that quantity squared plus 3. And you should be looking at this and saying, hey, that's kind of nasty. It's not looking pretty. So already it's not looking good off the bat. If we simplify this, what we get is I get x minus 3 times x minus 3. Actually, I'll write it out like this for you. X minus 3, square root of x minus 3 minus 4 times the square root of x minus 3 minus 4 plus 3. And what we get is we get the square root of x, we get x minus 3, root x3 times root x minus 3, minus 4 times the square root of x minus 3. Okay, that's from here and here. Then we're going to get another minus 4 root x minus 3. And negative 4 times negative 4 is a positive 16. Okay, and we have our plus 3 tacked on. Squeeze that guy in. So simplifying this, and we'll make it to where it's actually viewable, we have x minus 3 minus 8 root x minus 3 plus 16 minus 3. So what ends up happening is this negative 3 does not cancel. What ends up happening is that it combines with this negative 3 to be minus 6. So we get x minus 6 plus 16 minus 8 root x minus 3. So we get x plus 10 minus 8 root x minus 3. And this is clearly not equal to x. So what that means is it means that f of x is not an inverse function of g of x. And vice versa, right? G of x is not an inverse function of f of x. So we have shown what we wanted to show, and this is a non-example. Moving on to this example, this one will be much cleaner compared to that last example. Here I have f of x is equal to x plus 4 squared minus 1. And I have g of x, which is equal to the square root of x plus 1 minus 4. And we're going to go ahead and compose these. I'm going to see f of g of x. And what I want is I want this composition to be equal to x. So what I have is I have x, which I'm going to go ahead and replace with g of x. This is what I'm plugging in. Gives me the square root of x plus 1 minus 4. So that is x, and I'm actually going to put this in parentheses. That's my x value. Plus 4, and I'm going to square that quantity, minus 1. Okay, so simplifying, here my negative 4 and my positive 4 cancel, so I get the square root of x plus 1 squared minus 1. Well, root x plus 1 squared is just x plus 1. I bring down my negative 1. These 1's cancel, positive and negative, to give us x, which is what we wanted. Okay. So now I'm going to go ahead and I'm going to compose f of x within g of x. So I have the square root of x, which I want to plug in my f of x function. So I have x plus 4 squared minus 1 plus 1, and then I get minus 4. Okay, so again, I hope you see here, you see g of x, and instead of an x value here, all I did was I replaced this with my f of x function that went in there. So I'm going to go ahead and simplify this function. And what happens on the inside of my square root is my negative 1 and 1 cancel to give me x plus 4 squared. And on the outside I have a minus 4, which gives me x plus 4 minus 4. Right, my square root and my square cancel. We can cancel those. And x plus 4 minus 4 is equal to x, which is what we want. So both of these functions were equal to x. So I have f of g of x is equal to g of f of x, which is equal to x. So therefore, f of x and g of x are inverse functions. Okay, please go ahead and try this practice problem on your own, and I will post the solutions. Okay, so hopefully you have tried this problem. Here are the solutions. And these are inverse functions. Thank you for watching. Like my video. Go ahead and give me a thumbs up, and I will catch you next time. Thanks, bye.